Yep. All right. So our first FRQ was our calculator required FRQ using our handy dandy table here. So you were given a table of values. And part A, it asks you for the function of, well, you were given a table of values. You were given g of x, which is 2 natural log of x. And then it talks about h of x. H of x is a composition of g of f, g and f, right? Composition means I'm putting a function inside of a function. Agreed? So for that, Hudson, we're grading our FRQ, by the way.
Okay.
You know what? I don't. You do you, Hudson. All right. And so once you have those values, you're composing. So the first thing it asks you to do is to compose. So the first part that you were supposed to do was h of 4, which means that you are plugging 4 into f of 4. And I need to be able to zoom in. Let me see if it'll start off better. This to go away. All right, so let's start here. Boom. All right, so the first thing it says is to find h of 4 composed of g f of 4, right? So we are going to plug in 4 for f of 4. So that's the first thing you should have did was plug in f of 4. Once you found f of 4 from the table, f of 4 is 3. Do we see that? So we found that f of 4 is 3. You then are going to take 3 and plug it into g of 3. So 2 natural log of 3. 2 natural log of 3 goes in the calculator, and you should have gotten 2.197. If you got 2.197, then give yourself 1 point for that. So looking at your FRQ, if you got 2.197, that is a plus 1 point for yourself.
What if I rounded it to 2?
No,
I got
3 decimal places. I mean, right now, give it to yourself, but please don't round to 2 decimal places.
No, I had 2.19. I didn't have.
You 3, remember? Truncate at 3. Okay, it's always 3.
What A?
Yes.
Mm-hmm. Did they make you walk?
Mm-hmm.
My bad. I wasn't trying to do what I need to be doing.
Yeah, we're going over the questions and seeing how the points would be given during the real test.
Taking out like my grade.
It's just a review, Hudson.
Okay, just making sure. I'll do it.
Because you'll need to turn in your grade sheet for me. All right, so we have the 0.1. So then now it says from the table, it asks you f of x, find all the values of which f of x equals 3, or indicate there are no such values. You're literally going to the table, going to f of x. I get a 3 at 2. I get a 3 at 4. So there are f of x equals 3 at x equals 2 and x equals 4. To get the full point here, you need to have x equals 2 and x equals 4. In theory, yes. So if you only put 1, then for our grading thought process right now, that would be a 0.5, not a full. Okay. Looking at example at this problem, part A, should these be problems we get wrong? Or should these be give me FRQs? But should they be give me FRQs? Yes. Okay. Because this is just a build on from Algebra 2. Okay. So keep going. On part B, we had find all the values of x as decimal approximations of g of x. So this is using your calculator. So you're looking for g of x equals 3. When you're looking for g of x equals 3, that's using the calculator. So I'm going to go to the calculator. G of x is 2 natural log of x. And you're looking for when does it equal to 3. I'm going to try and be Desmos' friend again and see if it likes me.
Did we go over part C for question number
1? We're only on B.
Oh, I thought.
Oh, I was like, wait, did I say B?
I think we didn't do number.
We did. Remember, we're here on B.
Okay, I understand.
Yes. Hey, remember I had to give y'all the full sheet? Remember, came back through, gave you the rest of the problems. Yeah. All right, so back to the calculator, we're good? All right, so I'm going to try again on Desmos. So I'm going to graph g of x, which is 2 natural log of x. So I'm going to go to here. I'm going to graph g of x equals 2 natural log of x, ln x. Okay? Yes. Were you not here Wednesday? I gave it to you Wednesday. I passed them on Wednesday. Yeah. Is it in your binder?
Okay.
In the back? I'll double check. Give me 0.277. All right, so we're looking for when this equals 3. When you're using Desmo, you have to put in y equals so that it'll graph. If you just put in a 3, it will not do anything. You have to put in the y equals, and it asks for points of intersection, right? So for 2 natural log of x, when does it equal 3? Well, it equals 3 at one location. Does that make sense?
Yes.
Okay. And so therefore you only have one value, one location, and you get 1 point for identifying that location.
One point for each total thing.
Okay. Again, I'm not sure what happened there, but all you're doing is looking for that point. Okay. Here you're describing the end behavior. So this is something written in words. So for part 2, it says determine the end behavior of g as x increases without bound. Okay. As x increases without bound, that means x is heading towards positive infinity. So when you look at the graph of g of x as x is increased without bound, g of x increases without bound as well. So therefore, what they're looking for is you writing the end behavior with limit notation. So if you wrote the limit as x goes to positive infinity, g of x equals infinity. Yes.
I put limit x equals infinity and x bottom x. Does that count?
Say that again.
I'm looking at it. He put he just didn't put the G.
No, it depends on your grader. They may not give you credit because that's not correct limit notation. So what you're being graded on is your ability to write your end behavior with limit notation.
So if I can draw
You have to describe your limit. What is your limit heading towards? Did you put x is going to infinity?
Yeah.
And then g of x equals infinity? Then that's all that needed. Yeah. Yeah. No, this is what they're grading you on. So what they're looking for is your end behavior with limit notation. Yes.
Hold on.
To which? Scroll down. Okay. And that's what they're looking for. Then you didn't answer the question. Yeah. You wrote the limit, but you didn't answer. Like you wrote it, but you didn't say what g of x was doing. So that's why they wouldn't give you the point. Okay. All right. But we see that the goal here is the end behavior with limit. The rest before, cool. But what they want to make sure is that you can write this, right? The end behavior using limit notation. All right. On part C, which goes back to the original one, the original test. It is C, does the function of f have an inverse? Okay. How do I know if the function of f has an inverse? That means that it is a one-to-one function, right? One-to-one function means that my x's do not repeat and my y's do not repeat when I'm looking at a table. Okay. When we look at the table for f, are they repeating y values? They are repeating y values, right? Because there are repeating y values, then function f of x does not have an inverse. Okay. So in order for it to have an inverse, that means that it has to be a one-to-one function, which means that x's and y's both do not repeat. And because we do have repeating y values, then therefore it is not. Okay, so it's looking for you to justify, and the main thing is stating that f of x does not have an inverse function. I think you would get credit because technically it didn't ask for a reason. It didn't say why. Right? All right. On part 2, it says give a reason for your answer. Now you're telling me why. Okay. So part 2 is saying, why did you put no or why did you put yes? Okay. And the simple question would have been that f of 1 equals 1. F of whatever your reason could be, you would write. However, the one thing you will not get credit for is if you write fails the horizontal line test. Okay. You can write that the function is not mapping 1 to 1. You can write anything like that. But if you write fails the horizontal line test, it is not sufficient.
Does this not include as well? I put the graph f is the maximum, 5 minimum at both both intervals.
No, the maximum has nothing to do with y. It's an inverse.
Yes. What if that word is
Has what repeating numbers? So you would have to be specific what's repeating. So if you had said the output values are repeating in f of x, or if you just have to be very specific on what's repeating. Okay. All right. Any other questions about part C? Okay. So FRQ1 is a total of 6 points. On your sheet that you have, your grade sheet, you're going to write the total amount of points that you got from FRQ1. Yes. Yeah. So write the total amount of points on your grade sheet. Did these points push anyone into a 3 or a 4? Did the points push anyone? There you go.
I got, give me like the.
Yeah, so far, did your total increase by a lot? What pushes you?
Like the AP score?
Mhm.
I'm almost at a 4.
Almost
I
at-
take one more question, right?
All right.
I know.
At the bottom of your grade sheet.
Is it a bit to respond?
Hmm?
Actually, our grades
You're writing how many points you got?
for section 2.
Yes, your multiple choice.
Oh, I'm at a 4 now.
There you go. All right.
I'm not gonna study now.
No, don't stop.
I think you should not study at all.
Really?
This is good enough.
If not, you should try to bring your score down.
Ignore Oscar's advice, everyone. Do not listen to Oscar in the recording. Oscar is delusional. We do not bring our score down.
What did it say for C?
For C2,
That's the method you
which one?
study. Don't sleep.
The reason? Oh, you have to give your reason. Your reason cannot include fails horizontal line test. What? I told y'all that. Why do you think I've been stressing multiple choice?
Should make it 3.
No. Yeah. Someone messed up. All right. Are we ready to go on to the next part? The next calculator part? Okay. So on the next calculator part, we had our ecologists begin studying a certain type of plant species in the wetlands area in 2013. In 2015, which is T equals 2. Notice they're telling us that 2013 is our 0. Does that make sense? Because they said that T equals 2, we know that 2013 is our 0, our starting, okay? There were 59 plants, and then in 2021, T equaled 8. T equals 8, there are 118 plants, okay? The number of plants in the species can be modeled by the exponential model. P of T equals A times B to the T, where P of T is the number of plants during year T, and T is the number of years since 2013, okay? First, it says use the given data to write 2 equations that can be used to find the values for constants A and B in the expression of P of T. All right, so you have 2 equations, and the 2 equations are based off of you just plugging in what's given to you, right? Sometimes it helps writing them as ordered pairs. So we have 2, 59, and then we have 8, 118. And then all you're doing is plugging them into the function that is given to you. Okay? They gave you the model and everything. You just had to plug them in. Okay? So you had to have both of these. So A, all right, A times B to the 2 equals 59. A times B to the 8 equals 118. If you have these two equations, you give yourself 1 point. If you only had one, how did you do part 2? Did you use all calculator then? Because we've learned it, Matt. You probably use the calculator. It's okay. All right. So next year, now you're solving for your A and your B. Okay. So the way to solve is to solve one of these equations for A and substitute it into the other. So I solved for A, which became 59 over B squared. I substituted into the other one, which gave me 59 over B squared times B to the 8. B to the 8, B squared becomes B to the 6, right? Does that make sense? Divide, subtract. So you're left with 59 B to the 6 equals 118. At this point, honestly, you can solve this. However, using the calculator, you can do whatever. The main thing is here, they ask you what are the two equations that you can create, and how you solve to get down to here is up to you, okay? And then ask you to find the values for A and B. So I'm going to show you the calculator method, strictly calculator, using to solve them. Is that cool? All right. All right, so our values that were given to us, I'm going to actually make sure I'm in the right calculator. So let me go grab our AP calculator. Yeah, everything is slowing down, I think.
There's supposed to be 1.122.
All right, so our values were 2 and 59. And what was the other value? 8 and 118. Thank you. But you will on the next one, right? Okay. Are you on? Okay. So now if we are here and we have a table created and they gave us the fact that we're doing an exponential model, right? Because I'm doing an exponential model, I can come in here and type y1 tilde a, b, and then shift x1. And I can let the calculator, it just asks me what are the two that I would start off with? What are my values, right? After that, how you get the next part is totally up to you. Okay. Could I go through the algebra to do it? Yes. But at this point, if I have a calculator in front of me, why not create the regression and let the calculator figure out the rest? So notice that my A here becomes 46.82833. My B is 1.12246. Does that satisfy what they're asking me for? Okay. Can you, again, this is by hand, nothing wrong by hand at all. Okay. But to guarantee that you're getting both values, okay, it's there for a reason, and they put this on the calculator part, and this is the calculator that you're going to have access to. Does that make sense? So I was able to do it because this is the AP calculator that's going to be given to you on that test. All right. Questions? Okay. Anytime it's asking you for a model, that's a regression, right? So anytime it's asking for a model, I'm going to create a regression if there's a calculator in front of me. All right. Hold on. They keep calling me, so there must. All right, here we go. All right, so how do we feel about it afterwards? Yes, no, maybe so? Feeling a little better? No, stop saying that. All right, on part B, this goes back to the half sheet. Remember, it got cut off. So back to the whole sheet with part B. It says use the given to find the average rate of change. Guys, if we're missing average rate of change problems, we have a problem. Okay? Average rate of change, remember, it is the change in your y over the change in your x, right? So if I'm measuring that, that is going to be my y2 minus my y1 over my x2 minus my x1. This problem should not be missed.
Can you what A is?
Okay, there's no reason why we're missing this. The problem gave us our two values, right? We had our t of 59. We had our our t of 2 at 59, our t of 8 at 118. And so now all you're doing is calculating their average rates of change, okay? So their average rates of change, simply we're just subtracting and dividing. Finding the average rate of change. The key thing is to get the full 1 point. You have to explain what it means in this terms of this problem. Okay, so the average rate of change is 9.833 plants per year. So I will give it to you now, but on the test, please make sure you define your units. What are you measuring? Okay, put the one now, but be mindful.
Oh yeah.
Right now, you're fine, but I need you to make sure that you understand. In order to get the full 1 point, you have to tell them what that 9.833 represents.
No. Oh,
Hold on.
wait, it never sounded like
I know. Oh, yes. I only can show you part because I have to go on to the next one for the full B. Yeah, I only can show you parts 1 and 2 because the other part took up a lot more space. So it's on the next slide. Huh? You have to specify that this is your average rate of change. So whether you write average rate of change or you put plants per year lets them know that that's an average rate of change. Number 2, I have to go on to the next page. It was too much to put on one slide. No, both parts. All right, so then it says the average rate of change. So we found the average rate of change, and it says find the line, the secant line, right? Use the average rate of change to estimate the number of plants for t equals 2 years. Okay, I'm going to show you by hand how you would have done it, but then I also will go over with by calculator how you could have done it. Does that make sense? Okay. You can zoom out. And we're going to click on to the next, okay? So now we're on to the next part. Continue on with part B. So you're just basically finding a linear equation, a linear model, correct? That is all it's asking you. What would it be for a linear model to produce and then figure out what it would be at 10. To find a linear model, you have to have what? A slope and a y-intercept, correct? Slope, y-intercept, slope, y-intercept. Well, our slope is our rate of change, correct? Your A-rock is your slope. You can go through it here and then you can figure out all the longest way of doing it, which is finding slope, finding y-intercept, and all those good things. Then once you have your linear equation, you then are going to calculate what is 10. Okay, I'm now going to do it in the calculator. Is that okay with you?
Yes. Can you please show us the calculator?
Oh, are they all work on?
You get 1 point, 1 point, 1 point. All right. The easier one. So I'm going to go to the calculator and I'm going to clear this out, clear this out. I'm going to add a table. The table is going to be based on the values that I had. So we had that, what were our values? I don't have to go back and forth. What were the 2 points that were given? How do we find our A-rock? What do we use? Find our A-rock, we use. What are the values that we use? A-rock, we use 2 of 59 and 8 of 59. The same values that we already had, right? That's fine. 2, 59, we had 8, and 118. When you're looking for their average rate of change, that's just your slope. That is just a linear model. Is that not a linear model? Did I not get the 9.833? Okay, because remember, average rate of change is just the line that connects them, right? So essentially, I'm just looking for that slope. Did I find it? With just using the regression model. Okay, so now that I have this, I now can say, okay, this is the model for finding these values and finding the average rate of change. Once I have this model, I can then use it to find the other values, right? What is at 10? What is changing? Okay, you have the tools to make it easier on these parts. All right, you just have to use them. All right, it's a calculator part, so don't be hesitant to use the calculator the entire time. Is it beautiful to see all that math worked out? Yes.
Yeah.
But at this point, our goal is to get through this, correct? Yes, it is more beautiful to get it right, but it happened. All right, does that make sense? Yes?
Yeah.
Good.